In 4.3, we try a method other than factoring in order to solve the quadratic equation. And we're going to complete the square just like we did in our quadratic functions. And remember, that allowed us to write a quadratic function in vertex form. And in this case, it's going to allow us another method to solve the equation when we set it equal to 0, the quadratic equation. Okay, so it's going to use the same method to complete the square. Okay, and this actually is really good because if you can't factor, sometimes you can complete the square. So if you don't have factors that are whole numbers or solutions that are whole numbers, completing the square is going to work where factoring won't. Okay, so let's just try this equation. We'll try solving it, and we will complete the square for the function, and then we will solve the equation. And so I'll show you, it's just a little different way to do it, okay? So I'll just do this first before I do the graphing, okay? The first thing I want to do here is I don't like having those denominators, so I'll just get rid of them by multiplying everything by, I'm going to multiply everything by negative 20, because I want to get rid of that negative in front of my x squared as well. Okay, so negative 20 times negative 1/5 is positive 4x squared, okay, minus 40x minus 1, okay, equals 0. All right. So yeah, okay, now I'm going to complete the square. Remember, when we complete the square, what we want to do is we want to take that 4 out. So x squared minus 10x. Okay, we leave this negative 1 over here. And this is how we've done it. Okay, so I'm going to take that negative 10, divide it by 2 to get negative 5, and I'm going to add 25. Okay. What have I done here? Well, I've actually added 100 because I added a 25 that's multiplied by 4. So in order to keep my function from changing, I will immediately subtract 100. Okay, that equals 0. Now I have 4 times x squared minus, sorry, I'm going to write that as 4 times x minus 5 squared minus 101 equals 0. Okay, so that's now in vertex form. Okay, so I can tell that my vertex is going to be at 5 and 101. Okay, and to solve for x, okay, here's what I'm going to do now. Instead of factoring, what I'm going to do is I'm going to take this x minus 5 squared, and I'm going to move the 101 over here. Okay, and I hope you remember doing this. I think you did it in grade 10. In order to work my way in toward the x, okay, I'm going to divide 101 by 4. Okay, it doesn't go in, so I'll just leave it as it is. Now, again, to work my way toward the x, I'm going to take the square root of both sides. And I'll make sure that I take plus or minus the square root on the right. Okay, so if this is new to you, that's fine, because this is the only thing we're doing in this section. So if you feel like this is something that you should be familiar with, you can be learning it for the first time, that's okay. Plus or minus root 101. And I'll just change, instead of saying root 4, I'll just write it as 2. Okay, and then I'm adding the 5 to both sides. So x equals 5 plus root 101 over 2, okay, and 5 minus root 101 over 2. Okay, I'll just put that in my calculator and see what that should equal as a decimal number. So 5 plus the square root of 101 divided by 2, that's equal to 10.025, okay, and 5 minus the square root of 101, okay, divided by 2 is going to be negative 0.0249. Okay, negative, it's right here, negative 0.0249. Okay, so obviously not something you could have done by factoring because you're not getting a nice whole number. Okay, let's put that into that graphing calculator. Okay, we'll do our original equation before we did anything at all to it, just to get the best, the most accurate answer here. Okay, so we are going to say, I think it was negative 1 over 5 x squared, okay, plus 2x, Okay, and plus 1/20th. I'll just put these things in brackets just in case. Okay, so plus 1/20. Okay, and so here is my graph. Obviously, it's kind of a mess because we had those, we were zoomed out so much, but if we kind of zoom in, yeah. Okay, it won't let me do that because that's actually my minimum because I forgot my negative. That's why it's not letting me type 10 on top of that. Okay, so I get it back to our original, and then maybe work out from there. Okay, yeah, so you can kind of see we want to go a little bit higher on our max, x max, so we can see where our roots are. I meant to do 15. Okay, and so again, when I zoom right in on that and click on that intercept, it should give me my x value. So negative 0.025 and 10.025, which is exactly what we found. These aren't exact values. It's an exact value when you still have the root in there. But yeah, again, so you can see that's not something that you would have been able to come up with just by completing or by factoring, right? Because you do have that radical in your answer. Okay, so let's see, how much more do I want to do in this lesson? So okay, so it just says, yeah, it just asks us to graph it. So that's good for that part. We'll just take a look at what it says here. You can solve quadratic equations of the form ax squared plus bx plus c, where b doesn't equal 0, okay, or where b does equal 0, or if you write them in vertex form, okay, by completing the square. And we saw that before, right? Maybe, I think. If you solved an equation like this, because there's no x term, there's just an x squared term and a constant term, you just put the x squared term on one side, you put the constant term on the other side, and you took the square root on both sides, you know, including plus or minus the square root. Okay, and now we're saying if you do happen to have that x term, where b doesn't equal 0, you can rewrite it in this vertex form, right? And you can do that by completing the square, and then you have, again, the squared term. Okay, it's not just an x squared, it's an x plus or minus some number, and a constant term, and then you can take the square root of both sides, just like you would here. Okay, so we'll try a few examples. I think if you were good at completing the square in the last chapter, you shouldn't have any trouble here.